So we have antique geopolymers. These antique geopolymers must follow a prerequisite. They must be easy to implement. We must have mineral resources in great quantities. This is a technology that is not concrete. It is not regular gypsum. There is no cement added to the system, and we are not using crushed stone. On the opposite, we are using the knowledge from geopolymer, from geosynthesis, from geochemistry, from mineralogy, from geology, and we are using naturally weathered stone instead of crushed stone. In the case of the Giza material, we have an agglomerated stone that is a mixture of 95 to 97% by weight of limestone that are shells, fossil shells and calcite, to which we add 3 to 5% by weight of a geological glue that is a geopolymer. So this will explain why geologists see nothing. You'll see in the literature dealing with the contradiction of my theory, and you see in several papers written on the internet that it is very easy to look at a stone and to detect if it is a natural or an artificial one. Wrong. This is not the case for geopolymeric limestone, and it is not the case for the Egyptian limestone blocks that are making the pyramids. And I have to show that in fact each time that geologists or mineralogists are looking at this type of stone and claiming it will be very easy to detect that they are not made of the system that I am claiming, that is reagglomeration, they fall in the pitfall of the thin section optical analysis. What is the problem here? The problem is that we are dealing with a material that is an aggregation of fossil shells. You see here the shells that are constituting the pyramid blocks. We have 95% of shells, and in between a very tiny amount of the binder that is called micritic binder. So when you make a thin section, it is obvious that what you see are the natural elements, that is, the shells. 95% of what you have under your microscope lens is natural shells. And we are just discussing the 5% that are constituting the micritic binder, the geological glue. And if you don't look at the geological glue very precisely, you see nothing. At the beginning, I had to study some stones, some genuine stones, and I discovered on this lower sample here the presence of strange artifacts that I called filaments. And then we have a lot of air bubble. This is a stone that is covered with a synthetic coating. This was in 1982, and then after, for several reasons, essentially after 1990, I stopped doing any research on this material, and it had been only on the year 2001, 2002 that we started again to reconstitute limestone blocks like the ones that we find at the pyramids. And we made several limestone artifacts in the laboratory, and we will see later in great quantities. And we took these reagglomerated limestone made in 2002 to two different geological renowned laboratories in France. The first one was the Bureau de Recherche Géologique. This is the RGM. This is the French Geological Survey. And the second at the Museum of Natural History in Paris at the Geological Department. We gave them two samples of the limestone that we had re-agglomerated in our laboratory at the Geopolymer Institute in Saint-Quentin, France. And we told them, look, we found this type of limestone. They seem to be strange for us. Could you tell us what it is really about these stones? They made thin section, they wrote a report, and this is what they got. This is the thin section of what we gave them. Obviously, you see the big nummulite, then other natural artifacts like the quartz or the echinids, and in between the micritic binder. The micritic binder is a binder that it makes of very small particles of calcite, and they claim that this was the thin section of a natural nummulitic limestone. This piece of artifact was made in our lab and had up to 10% by weight of modern geopolymer. They could not detect it under the optical microscope. The binder that we used to re-agglomerate the stone had been claimed to be natural micritic binder. So if I don't say, if I don't tell that the piece of limestone has been made in our laboratory, geologists and mineralogists will claim, will state that it is a natural stone, and this is also the case for the samples that we got from the Egyptian monuments. So I asked my scientific colleagues to look at a way in order to try to determine the artificial nature of the micritic binder, of the geological glue. And the only way to do it, the practical way to do it, is to use electron microscopy. This has been done recently by a group of 3 scientists, Michael Barzoum, Gangli from Drexel University in the US, and Gilles Hugues from the CNRS in Paris in France. They published in December 2006 in the Journal of the American Ceramic Society the results of the analysis under electron microscopy, and they claimed microstructural evidence of reconstituted limestone. You'll find additional information in my recent book, They Built the Pyramids, and also in the book Geopolymer Chemistry and Applications.